Hello, hello. This is Mrs. Gervasio here with Tuesday's homework. Okay, be sure to watch and re-watch the tutorial. Pause for the practice problems and of course come back and check and see how you did. Complete the homework at the end of the tutorial and of course show all of your work.
We can also draw angles with a half circle protractor. Here we're asked to draw an angle that is 35 degrees. And it's important that we choose an endpoint. We line up our protractor, or we line up the 0 on one of our sides. And it doesn't matter here in this first problem which endpoint we choose, but we've got our center on the vertex, or what will become a vertex. We've got 0 on the starting side. And we take a look again, which 0 are we using? The inside or the outside track? Well, we're using the outside track. So we're just going to count 10, 20, 30, and between 30 and 40 is 35, so we make a dot right there. And then we're going to move our protractor out of the way, and we'll make sure that we grab a straight edge to make our finishing side. So we grab a straight edge, because we don't want to freehand this, and we draw a ray coming out of point H. And we know now that the measure from our starting side to our finishing side is 35 degrees. In our second example, we're asked to draw a 150 degree angle using ray CD as one of the sides. But we wouldn't want to use D, because D is not the end point of the ray CD. We want to choose the end point of the ray CD, so we choose point C as the vertex of our angle. So when we put our protractor on here, we put the center of our vertex on point C, and we line up 0 with our starting side of our angle. And we see again that we're using the outside scale, not the inside scale. So here we count up all the way past 90 to 150. And once we get to 150, we go right outside of our protractor to make a small little dot. Once we do that, we can remove our protractor and grab a straight edge,
Which you can actually just use the bottom of the protractor as your straight edge.
Because we are not going to freehand our angles. We're going to make them very exact. And when we grab our straight edge, we're going to start at point C and create another ray through that point that we made, that pencil mark that we drew, and we know that the angle we just created is 150 degrees. We can take a look at another example. Here it asks us to draw a 60 degree angle using ray EF. Remember, F is not an endpoint, right? We're not going to create an angle something like this. We're going to use the endpoint of our ray, which is E, to start our angle from, or use as a vertex for our angle. So we put the center of the half circle protractor on our vertex. We make sure 0 is on our starting side. Make sure 0 is on our starting side, and we count up to 60 degrees. And at that 60, we're going to be using, again, the outside scale. So right outside that outside scale of 60, we make a point, and we grab our straight edge, starting at endpoint E, or vertex E. We're going to draw a ray straight through that 60 degree mark. And we know that this angle is 60 degrees. Is it possible to use a half circle protractor to draw an angle that's larger than 180 degrees? This is challenging for some, but let's take a look and hopefully we can make these types of problems easier. Here we're asked to draw an angle using a half circle protractor that's 330 degrees. But we know that our half circle protractor, regardless of which way we choose or which scale we choose, only takes us from 0 to 180. So how could we possibly draw an angle that's 330 degrees? Well, let's think about it. What do we know? Well, we know that a circle is made up of 360 degrees. I'm sorry, not 36 degrees, but 360 degrees. And we know that our angle is 330 degrees. So really, our angle is going to look almost like a circle, but not quite. It'll actually just be, if we subtract 360 from 330, we know that the missing piece is 30 degrees, right? Our angle is going to be only 30 degrees shy of a complete circle. And this 30 degrees is an important part of how we can draw an angle this size using a half-circle protractor. To begin, we put the center of our half-circle protractor on the end point of our ray and make sure that we have 0 on the starting side. And we can count up to 30 degrees. So we count up to 30 degrees and we make a mark. And we're going to use now a straight edge to connect our vertex, or the end point of this ray, and create another ray through that 30-degree mark. Now, if we think about it, we've created an angle. We can kind of think of this angle as a 30-degree angle, right? But I've got a question for you. What would the measure be if we continue to start with our starting side and measured around all the way to our finishing side here? What would the measure of that angle be? Well, we know that if it was a full circle, it would be 360 degrees. So if we took that 30-degree portion and added it to this mystery portion, we know that we would be at a total of 360 degrees. So this sort of mystery portion must be 330 degrees. Let me draw this degree marker in a correct spot. 330 degrees. Because if we had 330 degrees plus that 30-degree section, we know that we would come a complete circle, or 360 degrees. So we can just simply erase that 30-degree mark, and we know that this is a 330-degree angle.
Okay, and here's the part of the homework that you need to actually bring into class tomorrow. Oh, that's okay. It's not very many problems at all. And this is your homework for tonight. You need to go ahead and take that paper protractor that I gave you earlier during class and draw each specific angle. And you can go ahead and just draw it on a piece of paper. So you would draw the angle for 90 degrees, write number 1 beside it, and then of course write where the angle 90 degrees would be. Do that for 90 degrees, 88 degrees, 180 degrees, 155 degrees, 6 degrees, 172 degrees, 45 degrees, and 171 degrees. And there you have it. There was your homework for tonight. Any problems, make sure to talk to me tomorrow. All right? That's it. I hope you have a wonderful evening. Bye-bye.